Good evening, everybody. My name is Bert Dicht. I am Vice President of Membership of the National Space Society. And on behalf of my colleague, Larry Ahern, Vice President of Chapters, I'd like to welcome you to our Space Forum, Space Analog for the Moon and Mars, how research at Biosphere 2 will prepare astronauts for actual missions. As always, we thank you for joining us in our series of Space Forums and Town Halls. And before I get into my regular announcements, I hope some of you caught the launch today. So just want to send out congratulations to Boeing and United Launch Alliance for their successful launch of the CTS-100 Starliner on its second mission. And it's supposed to dock tomorrow with ISS. It was a pretty spectacular launch, looked really beautiful. Wish I could have been there in person. So this is just taking from the NASA and Boeing feed, but looks great. So I hope some of you saw it. So as always, again, thanks for joining us for the Space Forum. We're going to go through some quick virtual etiquette, a few NSS announcements, upcoming Space Forums, and then we'll get right into the program, and then we'll close out for the evening. As always, I'd like to give you some guidance on virtual etiquette. Please feel free to submit questions. It is better to use the Q&A function because it goes right to the panelists and you don't have to pull everything out of the chat where there could be a lot of other things in there. So it's the best approach, but feel free to use the chat as well. I only ask that you be respectful of the panelists and the audience because in many cases, everyone can see that. And it is best to view the session in speaker mode. So that way you only see the person who's speaking and you won't miss any of the slide deck as well. We did get a number of questions and we'll certainly do our best to answer those that were submitted beforehand, along with your questions that come in during the session tonight. And coming up next week, it's our National Space Society ISDC 2022, Living in Space, the 27th to the 29th of May, a week from tomorrow at the Hyatt Regency Crystal City. We look forward to seeing you there. We're hoping for a great conference, the first one in a while because of COVID. And we've got a great lineup of speakers and sessions. Join us for this 40th annual ISDC. And believe it or not, 40 years ago was my first ISDC. I went in 1982 in Los Angeles when I was just starting out as an engineer at Northrop. So it's been 40 years. So pretty exciting. Hope to see you there. I always ask you to give to our cause. If you're enjoying the programming like these Space Forums and Town Halls, please make a donation to NSS. I will put this link into the chat a couple times during the session. And we, again, thank you in advance for all of your support, both for your membership and for your donations to us. It's much appreciated and it helps us do the great things that we're doing in NSS. Reminder to complete the post-Space Forum survey. It only takes a few minutes and it is completely anonymous, but your feedback continues to help us in planning these events, helping them make them better, more impactful, and more interesting, things you are looking for as members of NSS. So what's coming up? As we said last time too, our next Space Forum is going to be on the 16th of June. We're taking a break for the ISDC, and we've got a great presentation coming up, Becoming Awfully Preparing for Your Future Spaceflight Journey with Laura Forzik. Her new book, we'll actually give a couple copies of her book away. And I think you're going to find this a quite interesting presentation. The book is really fascinating. And then following that, we have another book to share with actually Laurie Garver, our former NSS director, and of course the former deputy administrator of NASA. She has written a book about her experiences Escaping Gravity, My Quest to Transform NASA and Launch a New Space Age. So we'll be in conversation with her, and that is Thursday, July 21st. We just confirmed that date with her. And we are working on August and September, so more to come as we get to our next Space Forums. So tonight, it's my pleasure actually to introduce our moderator, and you are very well. Anita Gale is our NSS Chief Executive Officer and a colleague of mine, and it is my pleasure to introduce her. And she is going to be doing the introductions for our guest speakers. And then when we get to our Q&A session, we'll be actually sharing the moderator function and hopefully getting to as many questions as possible. So Anita, it's all yours.
All right, well, thank you very much. We have a lot of questions, so I'm not going to put a lot of time into introductions. Suffice it to say that Kai and Trent are researchers at Biosphere 2. We've had questions about problems with Biosphere 2. Somebody even asked about closing Biosphere. It was never closed. There's been a lot of cutting edge research at Biosphere 2. It continues. Actually, it's increasing, and you're going to be learning from people who are doing research at Biosphere 2 what that amazing facility is going to be helping us with in the very near future. I met Trent. I haven't met Kai in person, but I met Trent at Biosphere 2. We had a design competition, the Southwest semifinal. We actually did that at the Biosphere 2 facilities, which are amazing for conferences, by the way. So thank you. And it was while we were at Biosphere 2 that Michelle Hanlon was there and a few other NSS leaders were there. And we were thinking, we need to get Biosphere 2 back into the space settlement technical community. So that's starting right now. Kai and Trent are both going to be at ISDC. They will be presenting in the space settlement session on Sunday of ISDC. And you will be seeing updates on Biosphere 2, we hope, at every conference we have from now on, because what they're doing is amazing and important. So I'm not going to spend more time. So we'll give them all the time that we can and answer as many questions as we can. Thank you very much. We are so delighted to have this presentation. Thank you.
Thank you. So hello, everyone. My name is Trent Tresch. As Anita mentioned, it was an absolute pleasure to actually get to welcome everybody and meet the NSS community in person this year for the space design competition. And today, I come to you as a founding director of the University of Arizona Center for Human Space Exploration. And before we talk a lot about the space analog for the Moon and Mars, I want to be with you kind of what we're building at the Biosphere 2, kind of our goals and vision for the future, and opportunities for the NSS community to come out and work with us and collaborate and really extend our reach into commercial space. So I'm going to share my screen here really quickly. Can everybody see that okay?
Looks good.
Thank you very much. So just a little bit of a backstory here. The Biosphere 2, is an incredible place in the world, just north of Tucson in Oracle, Arizona. And there's a lot of science that happens under the glass, we call it, which is within the biosphere itself, and then outside of the glass. So basically on the premises of the university grounds up north. And so we have everything from different solar array projects to radio telescopes. And then inside of the glass, we have the Landscape Evolutionary Observatory, which has just acquired more funding, a lot of kind of life cycle-based biology research, marine biology-based research throughout the oceans, because the biosphere, as it was turned over to the University of Arizona, really just became an incredible platform to enable different types of planetary and life sciences. And I'm going to let Kai, of course, talk about SAM specifically, but that's really how this idea for the Center for Human Space Exploration started as well. So in 2020, Kai actually gave me a call and he said, hey, do you want to come down to Arizona, to Tucson, and help me build a Mars research habitat? And I don't know about you all, but I cannot say no to that.
I'm going to interrupt. Are you advancing slides? Because we're just seeing the first slide.
It is just still the first slide, yeah.
Okay, I'm sorry to interrupt then. Thank you. Right, yes, so you got an offer and you said yes. Thank you.
So, after so much time spent with Kai over the last couple of years, the conversations that we would have as we were living together, as we were exploring the biosphere, getting acquainted with other scientists and researchers and even artists. There are all of these incredible opportunities that we started to see, and we kind of came to this conclusion that we needed to be able to share our resources with the greater community, not just those at the U of A or in Southern Arizona. So we created this Center of Excellence as mostly an umbrella to allow us the opportunity to kind of foster and facilitate further exploration for humanity. So as you can read our vision here, I think that I've given you a little bit of a background on kind of what led us to this, but we just started to identify that we have the opportunity to be impactful for the future of commercial space with just what we have through the university, the connections, and again, the greater community like you all at the NSS. So how are we going to be a leading center for human space exploration? Well, we, again, just want to make sure that we can take what we have and disseminate those things to students, to professionals, to artists, teachers, you name it. Anybody that is interested in space, we want to be able to enable you through collaborations, either putting you in contact, again, giving you resources. And I'm going to talk more about some of these very specific ideas that we've come up with. And again, just keep in mind that a lot of these are open to the greater community to get involved and be a part of. So as far as visuals go, I hope that this will paint that picture even further. So in the hexagons left-hand side, you'll see a black colored one labeled the Arizona Space Institute. And the Arizona Space Institute is an incredible organization run by Timothy Swindle that really oversees all of these kind of adjacent hexagon projects, right? Science and engineering, education, space medicine. You can see everything that has been worked on. And Arizona is really well known for a lot of telescopes, universal observations, satellites, landers, you name it. So some of these projects that you see in the hexagons are probably familiar with. You'll find us, of course, down in the human habitat section. So SAM, the Biosphere 2, the Mars greenhouse, these things where we're looking at humans in the loop and potentials to enable humans as a part of these projects, and then space medicine as well adjacent to that. But outside of the ecosystem that the University of Arizona has already created, we have, all of these kind of commercial opportunities, student learning opportunities through different universities. Some of these programs you're probably familiar with: Project Possum, Star Harbor, NASTAR Center. There's a lot of spaceflight training opportunities. And under Chase for human space exploration, we wanted to also develop those type of opportunities. But what's great about what we have here at the Biosphere is that if we need resources outside of what we're capable of at any point in time, we have these industry partners, right? And it's naturally, like, these natural connections within industry do just stem up. But I think that we have to take a step back sometimes and remind ourselves that, especially as a graduating high school student or an undergrad student, you're only really starting to develop the ability to reach out and connect with people or projects that you're interested in to, grow your skill set or maybe get a job into the future. So, as a center of excellence, we want to be able to foster that with students, be able to take them and put them in contact with Star Harbor, or the people we know there, or whatever research they're interested in at NASA. We can make those connections. If they want to do space research, Project Possum for noctilucent cloud tomography, do get to offer some training courses as well, or do we push them off to the Analog Astronaut Training Center, NASTAR, to go do anti-G straining maneuver type training? So again, we just want to leverage this community and continue to support those as we look to the stars. Now, the sandbox. This is kind of what I've coined what's happening at the Biosphere 2 currently. It was just announced that the Biosphere has started a Center for Innovation in different organizations to, again, support them in a different way, more so a commercial way, to create opportunities for the future. Some very fascinating projects that are included in there. And so we have SAM, we have the Biosphere, we have Chase, And all of these connections and all of these possibilities, you know, do we get to work with the University of Maryland and use their neutral buoyancy facility for research? Do we get to reach out to JSC and go there and use the NBL, you know, very historic and legendary operating sites, right, that we want to be able to introduce people to. So we're trying to create a place to play, and I guess a safe place in some manner to let people come and work on projects and collaborate and see where these ideas go, see how they grow. Now, this photo that we're looking at here is SAM, the space analog for the Moon and Mars, originally known as the test module. I won't talk too much about it, as Kai is going to give us a more detailed and advanced background. But why I wanted to show this photo is because Sam really is the backbone of CHASE. Because of Kai's work and his ability to grow the SAM project, you know, we were able to collaborate and just grow ourselves and grow the ideas of CHASE, like I said, over the last basically 2 years. So SAM, a fully hermetically sealed research habitat that was, again, kind of the test bed for the actual biosphere 2 itself, has kind of been laying dormant for the past 30-ish years that we've been able to repurpose now and reseal. We actually did our first full resealed test in July of last year, so it's come up on about a year. But that's all I'll say about that, so Kai can disseminate more info for us. But, you know, building off of the backbone of SAM, we started to think about, okay, again, pools. You heard me talk about the neutral buoyancy facility, or the University of Maryland has a diving lab as well. Obviously at UA here, we do have pools, but, you know, there are some restrictions. So one of those restrictions, we don't necessarily at the current time being have a pool that's deep enough to do analog research like the photo you see here. This is actually a program that we ran in 2017 at Fresno State University under some NASA education funding, where we were taking students, we were giving them leadership training, we were working with First Robotics to do robot building, UROV building, and then competitions. And then we also built this entire space habitat structure underwater, trained students how to scuba dive, gave them missions based off of historical like shuttle missions, and then we're able to train them in, you know, a closely simulated zero gravity environment for you know, potential space opportunities. So when I was working on this project back in 2017, I started to think, okay, this is great, but if we truly want to commercialize in space, not only do we need to provide, you know, kind of space camp type opportunities to get students interested in STEM and STEAM early on, but we need to take it a step further and open up opportunities that really haven't only been available for astronauts or you know, military types in the past. Granted, there were, you know, budgetary reasons for those things, goal and mission reasons for those things, but now, you know, as a society and culture getting to look at our future as a planet, well, what do we need to do? What do we need to teach in order to take those next steps? So how we're growing from this is we're going to implement pressure suits underwater. We're going to be doing those EVA type trainings underwater that are more so specific to actual like ISS or future-based type missions at, say, an undergraduate or graduate level that again will provide an experiential opportunity outside of the classroom, you know, where we can take engineer students and put them here, or art students and put them here, and really facilitate that opportunity. So pools, that was kind of an idea. Now, after the kind of neutral buoyancy idea, something very tangible for us to be able to compile was an online repository of space resources. So everyone here is probably familiar with the NASA technical servers and all of the information that's published on there. We've actually started something like that through the center, where we're able to again, disseminate some of these projects you see. So starting from the left-hand side, you have a 3D printed spacesuit component. That's actually a glove removal ring. The middle, the two photos here, actually a spacesuit glove for a lunar regolith project that we were able to design, funded under a NASA SBIR. And over on the right-hand side, you actually see a hard upper torso CAD model that you could, for example, CNC out of wood and overlay fiberglass or carbon fiber to actually make that hard upper torso unit. So because of our background in spacesuit design and operations and testing, a lot of this kind of initial information that we're able to share with everybody is based around spacesuits. But another exciting one that we just got made was a Apollo lunar hammer. So we have the designs for the Apollo lunar hammer. We can put that out for everybody to be able to either take to their local machine shop, do at home, and use for analog type research missions, or just have something to display, or give a gift to a family member. So the repository, we're starting just with a lot of these CAD models, then we're getting into other technical resources. We were lucky enough to work with some students here at the U of A engineering capstone. And with money again from NASA through the XHAP prize, we were doing a TC-TSAC redesign, which is a CO2 scrubber life support that has like these two adsorbent beds that swing back and forth to provide regenerative life support. And that complete study will be published through NASA, but then also we're going to house that in our repository. So give you an idea of information sharing, because I do believe that if we're going to continue towards the stars, there really has to be a good balance between, I think, collaboration and competition. And we're going to start to see more and more competition, but I believe that it really is key to maintain the ability to collaborate effectively. Now, something that I think my heart is most excited about are spaceflight training opportunities. A few years ago, we put together a participant spaceflight training program up in Seattle. And now we're absorbing that program down here at the University of Arizona. And we're looking specifically at providing trainings as a certificate through the university. So whether you're a student or a professional, anybody interested to take a spaceflight training course, you're able to, and we're trying to offer them at affordable price points to let anybody have access. So there are, of course, some overhead costs, but the beauty of the CHASE program and just the center is that each one of these individual projects that we're touching on are able to really be maintained with low overhead. So if we have to close a program down for a time being, there's no problem. If we need to solicit funding for a very specific project, then we can focus on that project and deliver on that. So for example, right now we're looking for funding for a spacesuit training program. We have access to 2 full pressure suits at the Biosphere, and we'll have access to probably at least 2 more in the near future. So using our pressure suits, being able to develop an FAA approved flight certification. So through the university, you would get the certificate as well as a spacesuit, and then you'd also have that FAA stamp of approval on there. Of course, some companies are not using spacesuits, but they're still, in my opinion, definitely going to be pivotal for some suborbital operations, but then of course, extravehicular activity outside of any type of spacecraft and on any planetary or celestial body. So going back just to this photo that you see here, this was a survival raft system with what are called Gumby suits or survival suits, teaching students how to use those and egress a spacecraft. And you may be thinking, well, every space operator within our lifetime is going to have their own set of operation and rescue capabilities and so on. So training for those astronauts is going to be very specific to each one of those programs. And I agree with you, that is true. However, for the younger generations, and maybe you remember this, there's this cycle between needing experience to get the job, but needing the job to get experience. And so again, through education, I feel that's probably the most effective way to kind of break that cycle. And there's not a lot of spaceflight training opportunities that are at least affordable out there. Right now, if you're looking at a NASTAR or a Possum, you're looking at $5,000 to tens of thousands of dollars. Waypoint to Space, I believe, is doing spaceflight training for $50,000. So different levels of experiences and different specifics, of course, and deliverables. However, we want to be able to offer these programs for as much as, say, an open water scuba course. So you're looking at $300 to $500 kind of per person. Another project that I would say that we're moving towards currently is like mode 8 egress work. So during the shuttle era, if you all recall, the mode 8 egress was basically a skydive from the shuttle, kind of as a last ditch effort. So we're incorporating that into some of our training. We've been able to get some grants to do some research on parafoil deployment handle locations. Believe it or not, the spacesuit skydiving, near space skydiving world is taking off. People are really excited within that community to grow those opportunities. And so we're working right now under the center with the US Parachute Association to start to develop spacesuit skydiving standards. So just another example of a project that we have under Chase. How about exploration opportunities for students? A lot of parallels between deep submergence and space, pressure vessels for human occupancy, life support systems. This photo is actually taken from a submarine expedition Kai and I did last year, where we were tagging deep sea sharks. We were collecting water samples at depth as well to test for microplastics. Our team in total logged over 50 hours at about half a mile below the surface, and we were able to successfully tag a couple sharks and even discover a new species of comb jelly. So again, impactful experiences definitely have parallels into space, and we believe we can incorporate those opportunities and provide them. Now, probably the most exciting thing that I have to share with you today, or at least I think, is spaceflight opportunities. In Tucson, we do have Worldview balloons, and Worldview is doing space tourism as well as scientific projects, stratolight, so Earth observation and space observation. But by next year, they're going to be flying their stratospheric zero pressure, super pressured balloons to basically around 100 to 140,000 feet above the Earth's surface. Well, this is an incredible platform that the university is going to be able to use for upper atmospheric research, whether we're paralleling that to Martian atmosphere research, or we're doing things with inside a capsule, if we're doing microbiome studies, for example. So there's a lot of opportunity that we're having those discussions around creating those potentials. Lastly here, I just want to show you this photo of a MiG-29 flying at about 65, 70,000 feet above the Earth's surface, and what that view actually looks like. I would assume that a lot of you would resonate with the idea that by taking people to space and getting to show them our home planet here, that we'll be able to foster stewardship for this planet, sustainability on this planet, and then be able to take those, I guess, those values to other places within our solar system. And so a lot of people write off fixed wing opportunities because it takes a lot of energy and specialized aircraft to get to higher altitudes, like 80,000 feet for the U-2 Dragon Lady, for example, which is again restricted to the US military. But some of these aircraft are actually available. MiG-29s, there are commercial companies that operate F-18s and F-16s within the States. And we can use these platforms for about $20,000 to $30,000 a person to get up to these altitudes for science, for tourism, for impact. I mean, I picture taking inner city kids and raising grant funding, getting them in one of these aircraft and flying to see the curvature of the Earth, and at the same time listening to Carl Sagan talk about the pale blue dot. And I just feel if we are able to provide that we have incredible hope for our future. So thank you all for letting me tell you a little bit about the University of Arizona Center for Human Space Exploration. And I'm going to pass it over to Kai so he can share more so about his vision and story about SAM.
Thank you, Trent. I always feel inspired just by listening to you. I get goosebumps thinking about all the things we're going to be doing in the near future. I'm going to share my screen here. Hopefully this will work. Okay, can everyone on my screen?
Looks good.
Okay, excellent, thank you. Let me hide this. So, oops, back one. So again, my name is Kai Staats, and I'm the Director of Research at SAM. Actually, I'm going to turn off my video while I'm, well, is the quality okay with my video running? Just please confirm.
Yes.
Okay, great, I'll leave it running then. So I'm the Director of Research for SAM, which is a space analog for the Moon and Mars at Biosphere 2. And I'm going to talk just briefly about what we have accomplished and what we hope to accomplish at SAM. And the first thing I'm going to do, in fact, is actually break from slides and show a short video. I have Trent show it. Trent, do you still have it loaded up on YouTube? It probably will go smoother from your end.
Yes, yes, I do have it available, so I can share it whenever you're ready.
Okay, let me disconnect this. Just a moment. Stop share. Okay, Trent, go ahead, please. Thank you.
All right, give me just one moment here. I'm going to share the YouTube video from
I'm on
online.
a weak connection. I'm on a weak connection in the middle of the Navajo Nation right now, visiting in-laws. So I can't share video from here.
Can everybody see the YouTube?
Yep.
Oh, hold on. I'm so sorry, everybody. I needed to make sure I share the audio as well. Share sound. Okay, Kai, I'm going to start the video.
Perfect. Thank you.
We're now at about 600 parts per million.
What we're about to do here is take our zeolite, which is our adsorbent, and add it into the scrubber system, into the sorbent bed.
Thank you, Trent. I'm going to hopefully that got through to most people without too much hesitation. The same video is also available on our YouTube channel to share towards the end. So that was the first, basically about the first 15 months of construction of SAM. And I've also saved you about 40 slides. I hope that was more enjoyable than going through photo by photo. It's been an incredible opportunity to be a part of this and to direct this construction and fabrication effort. I'm going to go through just a little bit of it, really trying to leave as much room as possible for questions and answers. So I want to start with this basic question, which is, what does it take for our species to become interplanetary? And of course, no one answer. There's no one right or wrong way to do this. There are so many, hundreds, even thousands of players now involved in something that's way beyond even what the Apollo era saw. It's really exciting for those of us who were born around that time frame and lived in the shadow of that Apollo era and the excitement of what we thought would be a rapid race, back to the moon and then to the Mars and beyond. And of course, it's moved much, much slower than anybody had anticipated. So this is something we might envision. This is an artist rendering done by a good friend of mine, Brian Vierstig, and this, is not necessarily factually correct. There's a couple of issues with this particular design, but it does give us a glimpse of what we hope to be, some of the early settlements or construction on Mars. And the question is, how do we get there? What are the steps, and what do we need to do here on Earth in order to prepare for that journey? And Trent gave us a broad overview of all the different ways in which we can incorporate training and education and research and inspiration, as Trent said, for the next generation of a future of human explorers of something beyond planet Earth. So back in the 1980s, there were a number of very interesting, eclectic individuals who had found an opportunity, found funding to make real this incredible, audacious experiment called Biosphere 2. Now, Biosphere 2 was not the first habitat analog. It was not the first. The Roscosmos and some of the universities, or I should say research institutions in Russia, had done some extensive experiments with closed bioregenerative life support systems prior to this. In fact, they were inspirational and helped guide some of the efforts here. And this experiment, Biosphere 2, ran with their first team from 1991 to 1993. And as Trent explained, we are currently taking the prototype, the test module, which I'll come back to, that was built in 1986 and used from 1987 through 1991 as a means to test many of the systems, the architecture, the space frame, the solid stainless steel floor, welded floor. Just a side note, which I think is fascinating, there's 3.2 acres of stainless steel welded floor beneath the entire Biosphere 2, which is just mind-boggling. I'm not sure that's even possible today, given the cost of steel. So we are fortunate to be on this campus. It is an official University of Arizona campus, about 40 acres surrounded by 2,000 acres of mostly wilderness, still owned by Ed Bass, who funded the Biosphere 2 and is on the board of directors. So we look at some of the analogs that are available today and ones in the past. Upper left is Gene Shoemaker, who was from the University of Arizona, planetary geologist, and brought the Apollo astronauts to Meteor Crater, Arizona, to do some of these external analogs and training systems. We have, of course, the NBL at Johnson Space Center. We have High Seas in Hawaii. We have Hera at Johnson Space Center in the bottom left. We have the Lunar Palace 1 by Beijing University in the lower center. And of course, the Mars Desert Research Station, perhaps the most famous, has been running for more than 20 years now with hundreds and hundreds of teams. I was fortunate to be a part of a 2014 team there, which inspired my desire to build SAM. So these analogs, some of them are super high tech and very comprehensive. Some of them are a little more basic in terms of the facility. Some are focused on psychology, some on food studies, some on haptic feedback and tool use, some like the Lunar Palace on total bioregenerative life support systems. So you could say that Lunar Palace, the bottom center, was really a micro Biosphere 2 and much more realistic for what we'd actually do on the moon or Mars in the coming 1 or 2 decades. Biosphere 2 probably represents something 300 or 400 years out, is at my best guesstimate. So a space analog for the moon and Mars, SAM at Biosphere 2. I'm going to give you just a few artist renderings to give you kind of a total layout of the facility. So in the bottom left-hand corner, we do have the test module, and the lung is not shown here, but we have the test module building that Trent showed in his photograph. Since that photograph, we have added on a 20-foot shipping container, which would be the the crew workshop and also where the principal CO2 scrubber will be housed. We've added on a 40-foot shipping container. We're looking at the end of it now, which is the crew quarters and airlock. This is a functional airlock that was brought out of the basement of the Biosphere 2. And we are basically connected to an indoor Mars yard. This is not a sealed building, nor is it temperature controlled. The goal is to simply create a space in which we can have really a technical terrain park. If any of you have ever been snowboarding or skiing, you know that a terrain park are artificially created surfaces and jumps and hills and rainbows and flips and such that you can use to test your equipment and your abilities. In the same respect, we'll have this indoor 6,400 square foot Mars yard, significantly larger than even the one at NASA Jet Propulsion Laboratory, in which we will have a gravity offset rig, a synthetic lava tube, a space for inflatables, such that we can leave our habitat and go into another habitat and practice the ingress and egress. And so this, I want to go through just some of the SAM construction operations timeline. So phase 1, which was the test module restoration, that was our first endeavor last year from January through June of 2021. And that was, again, as Trent alluded, that was the restoration and basically the refurbishing of the original test module, which had been empty and left mostly open to the desert. For those of you who have lived in the desert, you know that if a building is left open, the desert moves in. So we were creating eviction notices for all of the lizards and snakes and rats and squirrels and taking over that space again. And we were successful in hermetically sealing that building again and pressurizing it for a 5-person, 4-hour test run. We promptly broke it open again and added on the additional structures that I've stated. We hope to have that sealed once again by the close of this. Well, technically phase 2 ended as of April 22nd with the Analog Astronaut Conference, which we just hosted last week, and phase 3 now starts. We do hope to have the facility sealed again by the close of June, and then we'll take the summer off because it's a little too hot, and we'll pick up again in October through December to finish the phase 3 and then welcome our first teams in January of 2023. The facility is not designed to be finished or perfect at any time. The facility itself is part of the experiment, just like the original Biosphere 2 project. The experiment is, does the facility work, and how do we need to modify the facility in order to support the research projects that are brought in by the external teams and our own teams, and how can we improve over time as part of the learning experience? So five basic science objectives. Now, these are our internal science objectives. These objectives are ones that we're interested in, but because we are building a research facility, the visiting teams do not have to comply with these 5. It'd be great if they do. They can bring in their own studies and their own experiments that may or may not align with these particular 5. So we have the transition from physiochemical to bioregeneration, and that is going to be really exciting. As far as we know, we'll be the first habitat analog in the world to start with a physiochemical or a machine-based CO2 scrubber. And as we grow our vegetation, mostly food cultivars, within the hydroponic space of the original test module, we will see a reduced reliance on that machine-based system, representing humans traveling to Mars and landing on Mars and moving into a habitat that's entirely mechanical. And then as the plants mature, seeing less and less reliance on that physiochemical or mechanical system. It is not our goal to fully replace that system, at least not if we have a crew of 4, but to just demonstrate that the plants themselves will reduce reliance on that. We're very interested in how to close air, food, and water cycles. And that is not only for going to the moon and Mars, but to help us better understand how we can become better custodians of our space here on Earth, which we have clearly failed miserably at over the last couple of decades. Studying the microbiome of the built environment. Man, when you close up systems like this and you've got people breathing and eating and excreting, the microbiome goes crazy. And we really want to better understand that system and how is it affected by transient personnel, as we have teams coming and going, each one of them bringing with them a small microbiome on their body. How will that affect that built environment over time? And as Trent alluded to, and this takes us right back to Chase, how do we test pressurized suits and tools and procedures and entries and exits and EVAs in the Mars yard? I should clarify, we have an indoor Mars yard, 6,400 square feet. We also have a 1/4 acre external Mars yard that's open for total modification. So if a team comes in and says, we need 3 craters, one of which is 6 feet deep or 2 meters deep, and one of which is 1 meter deep, we can do that. We can buy, we can borrow a tractor, rent a tractor, and facilitate that, sculpt it to the needs of the team, and so they have what's available, what's needed for them. And then finally, advanced computer model simulation, monitoring, and management. And I'll touch base on that just with one slide a little bit later. So in fact, oh, here it is. So the scalable interactive model of an off-world community called CMOC, this is actually what started this whole project. This is what brought me back in 2019 to the Biosphere 2. I'm just going to touch base on this loosely. This CMOC is available, funded by and made available by National Geographic Society. It's available for free on their website. You just go to cmoc.space, and there's video introductions. There's a full NGSS, Next Generation Science Standard Aligned curriculum for grades 5 through 8 and 9 through 14. And this model has gone through rapid and really impressive modifications and updates and improvements over just the last year with some new team members we brought on to the development. It's a Python-based model, an agent-based Python model, and is incredibly extensible. So with this, you can design your own Mars habitat. You choose the size of the crew quarters, the size of the greenhouse, the number of food cultivars, if any, the number of CO2 scrubbers, solar panels, batteries, the amount of starting rations, food rations, and you set the whole thing in motion and see if you survive. And it's really, really fun to watch what happens when kids especially get a hold of this. There's a teacher in Brunswick, Maine, who is currently completing a 7-week program that is built around this interface and around this system for her 7th grade students. So we're really excited to see what happens with that. So, and again, in closing, and I'm trying to leave as much space as possible for questions and answers, what can we learn about our home world as we prepare to explore the next? And that's really fundamental to not only our experience, but to that of the original Biospherians. They set out to build a Mars habitat and really became much more focused on the relationship between plants and animals and humans within the multiple biomes and closed ecosystem of that facility. And if you follow the lives of each one of those biospheres, there are 6 remaining. All of them have gone on to get their PhD. All of them have gone on to do amazing things within the world of both human and plant interactions, whether it's studying the coral reefs or doing plant ecology systems, to also, as with Jane and Tabor, starting the space perspective and both worldview and then space perspective with high altitude balloon launches. So I think we can all be inspired by what they've done. And I can only hope that Trent and I and our entire team will be inspirational in some fraction of that manner as we move forward. So this is, in closing, this is the first day that Trent and I were at SAM. I remember walking down there with John Adams, the Deputy Director of Biosphere 2, and I saw this for the first time in a couple of months after, COVID kept us there, or kept us away from this for a while. And I looked at John, I said, oh my God, did I really sign up for this? And he said, yes, you did. And he left. So Trent and I dove in on January 20th of 2020. So I just want to say thank you to the many volunteers and also staff members who have been an integral part of this incredible journey over the last year and a half of construction, deconstruction, working in snow and rain and an incredibly hot sun, and always staying positive and always working towards our end goal of having this incredible research facility. So finally, we like to engage research teams from around the world in hands-on scientific discovery to inspire the next generation to be engaged custodians of this planet while exploring new worlds. And I'll leave that slide up in case you want to copy down the websites for SAM and also for CMOC.
Thank you, Trent and Kai. Wow, you folks are busy. You are doing a lot. We're going to start by relaying some of the questions that were asked in advance, and thank you to Bert for collecting these. We had several questions that presumed or assumed, actually one said Biosphere 2 had been abandoned. There's one, the issue of the concrete reacting with the ambient O2 and reducing the partial pressure of O2s. And I guess we can summarize these with one of them. Let's see, there were some failures in the biosphere in the early 1990s. What have you done differently to ensure the research objectives are met?
I'll take that one. I want to start with a statement that is really important. There's no such thing as a failed experiment. There are failures to run experiments. There are failures to collect the data. There are failures to understand the data. And most importantly, there are failures to communicate the results to the public. So in this case, it was the latter. Biosphere 2 was a complete success as an experiment. We learned a lot from it. Yes, they injected oxygen about 500 days in. Their failure was to communicate that to the public in a proper manner. The gentleman who was running the facility at the time was not trained as a scientist and felt that it was better to maintain some of his, I guess I would say, exalted goals of this perfectly closed system. I think a scientist would have not declared the experiment quite the same way. And so he hid it. He chose to bring the oxygen trucks in at midnight and hoped he could sneak it in. And that was an incredibly big mistake, because 30 years later, that's all people remember. What we should remember is it's obvious. Go to Google Scholar and type in Biosphere 2 and look at the papers, look at the results that have come out of it. It's an incredible result. We learned an incredible amount, and it was not a failure. We cannot use the word failure in such an audacious experiment with so many lessons learned. And since the Biosphere 2 was terminated as a sealed experiment midway through the second run, which is a whole nother story you can learn about in a documentary called Spaceship Earth on Netflix, came out last year. Since then has been run as an open, although controlled environment ecological research center, principally focused on climate change. And I'll just give a quick example of the absolute success of this facility. In the early 2000s, or late 1990s, yeah, early 2000s, they ran an experiment in which they artificially increased the CO2 level inside of Biosphere 2 to 400 parts per million, which at the time was about 100 parts higher than the ambient, and the coral reef died because of the increase of the acidity of the ocean. And so we knew 20 years ago that the coral reefs would be dying. We knew it, and everybody's ignored it since then. So it's one example.
Can I
Wow.
jump in?
Yep.
Go for it.
No, just really quickly, it's something that somebody told me once, which I love to share when I can, is failure is the first attempt at iterative learning. And that's just stuck with me over time, every project. And so I hope you guys can learn something from that too.
By the way, I want to answer more discreetly. I want to answer one of the questions. So yes, there is the two things that were learned about that particular experiment. The first experiment is that the microbes they brought in for the soil, both in the agricultural area and the rainforest, they literally collected sewage from a nearby sewage treatment plant and brought it in as not raw sewage, but the results, brought it in to give it as rich a soil composition as possible, thinking, hey, let's give these plants the best opportunity. Turns out that microbes, just like us, consume oxygen, give off CO2. And so the oxygen was drawn down rapidly, and they couldn't figure out first why. The concrete curing, yes, the concrete was very wet, literally just poured sometimes weeks before. And so that chemical reaction also heavily affected the environment, probably in a positive way in terms of keeping the CO2 low. But those are two lessons learned. Don't bring raw sewage to Mars, and make sure your concrete is cured before you arrive.
So that prompted me to remember something that I heard when we were there. NSS leaders were there for the semifinal. And that was some understanding that young plants actually, instead of absorbing CO2 and creating oxygen, actually absorb oxygen to create CO2. Is that, do I remember correctly?
Yeah, I'm going to clarify. I knew you were going to bring that up, and I have to be careful. I'm not a plant biologist. This is not my area of expertise. All I know is that in my personal experiment, I haven't had a chance to confirm this for all plant life. In my personal experiment that I ran at the Biosphere 2 in 2019, I was growing barley fodder, meaning barley seeds in a water bath with no soil. And in that particular case, in the first few days of those sprouts before photosynthesis is activated, yes, in fact, they're creating CO2, not pulling CO2 in through sequestration. I know that's true for barley fodder. I cannot confirm that for peaches or apples or oranges or carrots or celery or anything else. So we have to ask a true plant biologist to confirm if that's exactly how it works for everything else.
However, the fact that even some plants do that is incredibly important for starting up new biospheres in space. Because we need to know that just planting plants doesn't create CO2 all by itself. There's some reverse. A question, the first question that was on the list of advanced questions was, have NASA astronauts come to Arizona's Biosphere 2 to train?
So Trent, I'll take this one, is that okay? So to date, NASA astronauts, no. So Biosphere 2 originally was not NASA funded and was not engaging NASA directly. There were NASA researchers, in fact, we know one of them who came to Biosphere 2 to look at and to comment on the way they were configuring the system and the way they were building their sensor arrays, but there wasn't direct engagement. We do now at SAM have a number of engagements with folks at NASA who are very excited about what we're doing. And we do expect to see NASA teams coming to SAM in the near future to use it for their studies. NASA is principally focused on psychology studies. They manage 5 analogs around the world, currently manage and fund 5 analogs. And to the best of my knowledge, it's principally psychology studies. That is an area that we as a team are not principally focused on. We're leaving that to the professionals because that can get kind of messy if you don't know exactly what you're doing.
Okay, thank you. All right. I think I know the answer to this one. Is the public able to visit the Biosphere 2 while it is occupied? Yeah.
Okay, so to clarify, we are not occupying Biosphere 2. We are about a quarter of a mile to the east of Biosphere 2. SAM is a separate building, a separate facility. The Biosphere 2 has been open for public tours for 20 years. We used to have pre-COVID 110,000 people per year as visitors. So absolutely, you are absolutely welcome. We're open 364, I think, days a year from 9 a.m. till 4 p.m. And you can just go to biosphere2.org, purchase your ticket. We have both self-guided tours and you can pay a little more for a guided tour.
And the tours are fascinating. So I know
Looks
that
like we lost Trent. I hope he's able to jump back on. Yeah.
Oh, we did, yeah. Okay, what kinds of food would be grown in the greenhouse for people to eat that would be living on Mars?
It's a good question. So that question is answered in a number of ways. One of the things the Biosphere 2 inhabitants, the Biospherians, learned is that they were nutritionally very healthy. And they had a number of food cultivars. I don't remember the total count, but obviously rice and beans. I think they had some maize. They had different kinds of lettuce and cabbage and spinach, all the things we would expect to have in a facility such as that. But what they learned is that they were nutritionally healthy, but they were calorie starved. They were hungry from the first week. The only room, if I remember what I've read correctly, the only room at Biosphere 2 during the first experiment that was locked was the room with the bananas, because they wanted calories and sweets. And so something we have to consider is 2 things. One is sometimes we'll choose foods simply because we enjoy those foods, right? Maybe strawberries. We just love the flavor of strawberries. But at the same time, does that particular food cultivar sequester CO2 as well as a complement or as a different variety? So we know, for instance, that wheat and sweet potatoes both draw down CO2 at a very similar level. They're excellent at CO2 sequestration, oxygen production. But we as humans, not ungulates, cannot digest wheat directly. We have to shuck it, we have to process it, we have to heat it, grind it, cook it. But sweet potatoes, we can eat right out of the ground. So if you have a choice between the 2, sweet potatoes are going to give you immediate gratification. They're going to give you higher immediate calories and sweetness. So the Biospherians grew sweet potatoes everywhere after the launch of the program, such that their skin actually turned orange. Their skin had an orange tint when they left because they were eating so many sweet potatoes. And Trent, was it Jane that said if she never sees another sweet potato for the rest of her life, she'll be okay?
Right.
So I think there's no correct answer to what kinds of foods we bring. It's culturally specific, but there will have to be a balance between what do we enjoy and what do we need for calories and nutrition, and what do we need as a CO2 sequestration agent. So there's really 3 answers to that.
And the Navy certainly understands that having good cooks in the galley helps the ship run better. Lots of good quotes on that. And also we know from friends who are astronauts that your taste actually changes when you're in orbit in zero gravity. And they find that they like spicy foods better in zero gravity. The astronauts actually come here. I'm near Johnson Space Center. They come here and select what foods they're going to have for their stays in orbit or on the International Space Station. And they'll oftentimes find what tasted good on the ground tastes icky in space. So it's an interesting situation. Another question that was provided in advance, and I will get to the ones in Q&A in a moment. What products are being recycled and repurposed for use on Mars? I don't know if that's a Biosphere 2 question, but.
Let's see, I'm trying to find that one in the list. Can you read that again, please?
Yeah, what products are being recycled and repurposed for use on Mars? That may not be a good question for it. It's kind of about 2/3 of the way through the list.
Well, actually, no, I'm going to answer in the way that I'm perceiving that question. So at SAM in particular, one of our fundamental goals is there's no waste. There's not going to be a single waste basket in the entire facility. I don't care if you're in there for 5 days or 5 months, there's no waste. What you bring in, you take out at the end of your mission, and there's no packaged goods. All the meals are vegetarian. All the meals are made from freeze-dried or dehydrated materials or the fresh produce you generate in the garden. Your water is completely recycled. Trent, in fact, has been researching and found a fully self-contained, fully recycled water shower in which the water literally is just in a loop. It's a few gallons of water that just loops around and around and around and is never in contact with any outside system, fully cleaned internally. So we are really demonstrating how we should be living on Earth today. No single-use plastics, no disposable packages. For how
you can teach a lot to International Space Station. One of the problems there is all the, oops. There we go. The last one I'm going to take from the ones in advance, and then we'll go to the Q&A during the presentation. I recall seeing ants running everywhere in the Biosphere 2 when I visited you many years ago. Is cross-habitat contamination an issue in Biosphere 2?
Trent, do you remember the story of the ants? Were those introduced, or were those originally? I can't remember if they were intentionally introduced or if they came in after they.
Yeah, no, I don't recall specifically what those the story is of animals moving in post seal, but we definitely see that nowadays, right? We have different insects that have moved in. We've got birds that have moved in. So for those of you who don't know, the Biosphere now is an open facility that you can come and visit. And so that definitely there is cross-contamination through habitats. I think that the staff do their best to make sure that if there's a research project, that there are the controls in place to work on that specific project. But there are people moving through constantly, so you're seeing changes in from my understanding, changes in bacteria or whatever is on the bottom of somebody's shoe as they track it through.
So there are ants, roaches, and crickets that move freely between all of the biomes, and we call them the crazy ants. They don't bite, they don't do anything. I don't remember the exact species, and I apologize. I don't remember if they were originally there. I think they were, and there were some insects introduced as part of the means to break down the underfoliage within the rainforest and some of the other biomes. If you don't have those insects, there's very little to break down leaves and fallen debris and material. There has to be something to break those down.
Going to the questions from Q&A, the first one is, will there be some equivalent to the soil bed reactor from Biosphere 2 days? It was said to eliminate the buildup of trace toxic gases in particular.
It's a good question. I am not familiar with, I apologize, I'm not familiar with the soil bed reactor. I'll have to look that up. So you've stumped me. Trent, do you have any information on that?
Yeah, I believe that's something that is can be integrated as a part of like a life support system, basically a giant filter, right? Like a carbon filter, like an activated carbon or SAM filter or something along those lines. So, SAM, as a platform to test all of these different technologies and operations for our future in space, I could see potentially scientists, researchers bringing in something like that to test within the system. But, where we're starting initially is going to be hydroponics for plants, as well as physiochemical life support system. So using our zeolites, for temperature, or humidity, CO2, and some other things obviously in there as well, but it's going to develop over time, right? And if there are opportunities that people want to bring that in to do that research on soil bed bioreactor type systems, then it's definitely feasible.
Okay, good. Another one, this is kind of a long one. How developed are plans to convert Martian soil or lunar regolith into usable soil. And actually there's a difference between dirt and soil. What's there now has no biota in it, it's dirt, and to grow things you need soil. For instance, website says converting basalt, but the real regoliths of either Moon or Mars are different. For example, perchlorites on Mars and elemental iron, glass, etc. on the Moon. And I'm not sure if you're doing
That's
anything.
a good question. It's a good question. I actually need to update the website to be clear. Absolutely, you have to have the perchlorites, you have to have the nasty stuff in there to be a true simulant. We are working with, is it Planetary Research? Trent, what's the company?
Regolith?
Yes, yes.
Yeah, so Off-Planet Research is based in Washington. Yeah, so they've supplied us with some regolith. And what's great about all these commercial space companies that are coming up is that you can pick and choose, right, what specifics mechanically or chemically you want the makeup to be for a certain part of Mars or the Moon and so on.
Yeah. So along that line, I need to update that part of the website. So thank you for the reminder. We've actually, that was one of our 5 science objectives, was to perform those experiments. We as our staff will not be focused on that, because we've since learned how many universities and how many institutions are already doing that research. So it's not necessary for us to become experts in something that we're not already experts in. So we will be welcoming other teams who are experts in that that perchlorate laden regolith transformation. If they want to bring those experiments into SAM, we will welcome that. And
I just posted in the chat to everybody as well. I'm not sure if you have all seen, but there was some Apollo lunar regolith that was lent to a university where they actually just grew some plants in that old regolith.
Wow.
Just this last week.
Yeah.
Yeah, that was news. Yes. Okay, another one. As the original Biosphere 2 had problems with simulating UV light effects on atmospheric regeneration and cleaning, are there some plans to simulate the even higher UV light from light fraction? I'm sorry, the even higher UV light fraction on Mars? There being less light on Mars, I'm not sure why there'd be a higher UV light fraction.
Yeah, the light fall on Mars is considerably less. It's roughly 48 or 50%, at least optical. I'm not familiar with the difference in UV versus optical, but I know that just because of the distance from the sun, the total light fall, the actual energy per square meter is considerably less. Let me read the question. Had problems with simulating UV light effects. I'm not familiar with their problem with simulating UV. I know that because of the glass structure, because glass itself, even without any film, is a UV inhibitor. So very little UV got through Biosphere 2, and the Biosphereans themselves were very pale. Atmospheric regeneration and cleaning. Okay, I don't know if we're talking about Holger. I'm not sure if we're talking about generation or breakdown of more complex oxygen molecules, or the actual just sterilization of the atmosphere. I'm not sure what that refers to. I apologize.
So we can ask the person who asked that. We may get down if you type a little bit more specific question. Another one is, this is a good one, especially for young folks who might be watching or listening. What are your expectations for career opportunities at SAM as you're starting operations and moving into later development phases over the next couple of years?
No, it's a great question. So maybe Trent, we can address that for Sam and then back to Chase. As for both of them.
Yeah, sure. I'm trying to double team here and answer some written questions. So
okay, excellent, thank you. So the opportunities for career, yes. So we will be building up a staff at SAM. It's going to be as a minimal staff in the sense that our focus is really facilitating the teams that come in. And so we will have a maintenance crew, which will probably be, these 10 fingers and those of our current team. And we'll also have an operations crew that receives the teams, that performs the training. We've had the absolute pleasure of working with Anastasia Stepanova, who was an engineer at the Sirius habitat in Moscow, Russia. She's now in the Colorado School of Mines as of January in Colorado, in Golden, Colorado. She was just at SAM last week, and she'll be coming on board, if everything goes well, in January as one of our crew members, or as our team members, to help train that. So additional team members, certainly over time, there may be opportunities to come in. The best way really, and the best thing to look forward to at SAM is bring a team. bring a team, get your friends together, get your classmates together, find a professor, and design an experiment or series of experiments, and contact us and raise the money and come in and work within our facility. Bring your ideas, your innovations. A lot of the questions here, even if we're not doing it, for instance, I saw now that Holger responded, breaking down larger molecules, of course. So breaking down larger molecules using UV light, that may not be an experiment that we want to perform, but you can bring it in. Bring in your UV lamps, bring in your heavier molecules or your molecule production. Let's see what happens. That'd be a great experiment to perform.
Okay, so it looks like questions have been answered in the Q&A. So Trent, did you see anything in the chat that we want to answer verbally?
My Q&A got it kicked me out, unfortunately, so I don't see a lot of that any longer. But in the chat, questions surrounding SAM, hydroponics versus aquaponics. What are we thinking about using?
Okay. Trent, do you want me to answer that one, or do you want to take a stab at it?
Yes, please go for it.
Okay, so we are currently focused on hydroponics. For those of you who may not know the difference, so hydroponics is basically growing plants without soil, and the roots are immersed in a water bath. And aquaponics, as compared to aeroponics, aquaponics is the use of fish, where you have these multi-layered or scaled beds. The top one is the fish aquarium, and the excrement from the fish, the nutrient-rich water, is then drained through successive, literally stair steps of plants that receive different levels of nutrients based upon that flow of that water. And in ideal world, one of those plants is something that the fish can eat, such as a rice paddy. So then you would grow rice or a grain that you can then feed back to the fish again, and it becomes a fairly self-sustaining loop in the ideal situation. We'd be certainly open to experiment with that. Again, that could be an excellent experiment to bring in. We've seen aquaponic systems, even at the Biosphere 2, we have one running up until just last year for a couple of years as part of a demonstration. They can be relatively small. They don't have to be huge. You could fit it within the space of an office desk. So that'd be a fun one to bring in and actually test. We're not expecting that to be a core function of SAM, simply because they are higher maintenance than hydroponics and a little more difficult to automate from what I understand. And so I could be wrong in that. So I don't think it'll be one of our core functions. Aeroponics, of course, is really spraying a mist or spraying the water onto the roots of the plants as compared to immersing them in the water. I believe that aeroponics has less evaporation than the water-based system, or at least less overall water use. If I understand, I'm not an expert in aeroponics by any means. I see one at the top here by Gregory asking about the lung, and that's something I failed to mention. So the lung, as far as I know, unless I'm missing some physics here, the lung would work on the moon or Mars. It's simply a pressure vessel. And it, instead of having an elastic membrane that exerts a pressure the way a balloon does, it has a mass on top. So we are using the lung, and the lung will in fact function into our larger space. However, the lung was used in the original Biosphere 2. There were two lungs, a south and a west. Both of them had 40,000-pound plates of steel that floated on a cushion of air and exerted the pressure to maintain the constant internal pressure, such that all leaks, there's always leaks, were moving from inside out, so they could claim a biomedical, or basically a seal, a hermetic seal. And so we have the same thing. We have a fully functional lung. That was one of the things we restored, and that lung will function as we expand. However, because the lung is compensating for barometric pressure changes on the outside and temperature changes on the inside, that lung moves up and down to compensate for those pressure differentials inside to outside. If you were on the moon or Mars, where you have very little to no, or I should say no to very little barometric pressure changes, then that lung would essentially be at its maximum inflation and just gradually decline until you introduce additional air using ISRU. So in our facility, because we've expanded the vessel, the lung is going to move much more rapidly and much more, it's more likely to max out and more likely to hit bottom. Therefore, Greg, in addition to the lung, we also have a automatic pressure regulation system that a University of Arizona capstone team built a prototype for last year. And it's fully functional. They use a Raspberry Pi and an off-the-shelf Home Depot air pump, but instead of drawing air in from the outside, they drew air in from the inside. So they were basically using it as a high pressure storage tank that was drawing air from the inside of our vessel, storing it, and then releasing it on an as-need basis, or drawing additional air in if it was overinflating, and it worked perfectly. So we believe we'll be able to expand that with a larger than Home Depot air compressor into something that's closer proximity to what you might see, for instance, in a scuba tank, which is 3,000 PSI instead of 120 PSI, in which case we could store a lot of air in a very small space and use that to augment the pressure differentials in addition to the lung.
Okay. I'm guessing Bert is getting a little bit antsy. I see two more questions I'd like to ask from the Q&A. And I think we're running over time. On the other hand,
feel free, Anita, go ahead.
All right, yeah, I see people are staying with us here. Okay, question, is there a polar/Arctic freezing cold biosphere planned as Mars at night, or as Mars is very chilly? It's kind of weird how it's, yeah. Mars is cold, so is there going to be an emulator of the thermal conditions on Mars?
I think that's called Antarctica. So
yeah.
we do not have at this point in time plans to somehow encapsulate SAM itself within a 200 degree below zero environment, nor reduce the pressure by 100 times. We do have another area at Biosphere 2 called the West Lung, which is no longer in use, that we would love to actually control. We'd be able to control the light completely, and we'd be able to reduce the temperature 20, 40, 50 degrees, but no, it'd be too expensive and quite the engineering effort to actually simulate the Martian atmosphere. I think that's why there are so many analogs in Antarctica. And also there's one in Iceland, for instance, that's actually operating in a lava tube in Iceland. Those are the best places we can find on Earth without having to build another $1 billion facility. So,
and although it does snow near Tucson, it also gets to be what, 115 degrees in the summertime. Yeah.
Biosphere 2 is up to about 105 during the summer. So it's tolerable, but not fun. Yeah.
Right. Okay. So finally, at least the final one I'd like to ask, how can researchers get involved with SAM and CIMOC?
Yep. So the best thing to do is I'm going to put into the chat. I'll put in the website one more time in case they didn't get it. SAMB2.space. So that's SAM and HTTPS. There you go. So there are contact forms on both of those. They both go directly to me. They don't go through any other committee or anything. They'll go directly to me, and I will do my B2.space has instructions. If you are a potential visiting team, there's some basic questions we ask. CMOC.space, everything you need is on there, and the Nat Geo hosted fully functional CMOC is available. If you are a university researcher and would like to install a local copy of CMOC, we do under NDA at this point in time until we start open sourcing parts of it. We do accept and work with a number of PhD students, for instance, who are using CMOC in their thesis. And we're going to be installing CMOC as an interactive kiosk at the Arizona Science Center in June and July. So the kids that come to the Arizona Science Center, which is tens of thousands per year, will be able to actually use CMOC as a kiosk in that facility.
All right. Are there any final comments you'd like to make, or something that a question didn't inspire?
No, I just appreciate everybody's time. I love talking about space and getting it to share with the community. And I think that we get to facilitate the future, and so hopefully together we will make a lot of these big ideas come to fruition.
All right, great. Bert, do you have any questions or comments you want to ask?
Yeah, just one final question. As an engineer myself, in understanding how you develop the SAM or develop a biosphere, because I saw pictures of construction. Do you bring in architects who are specialized in this, or is this something that's done in-house, working with your researchers?
No, it's a great question. So I have in my industrial design degree, as an undergraduate, I had 2 years of mechanical engineering, which really got that mechanical brain formalized. I also grew up on a farm in Iowa, and that gives you all the skills you need to do a lot of things, fixing, welding, cutting, priming, sanding. Trent, in a similar fashion, is is really good with so many different media, from plastic to different types of rubber and polyethylenes and metal. And so we also have the entire Biospherian team. All 6 remaining Biospherians are on our working group. So we're able to reach out, in addition to those, we're able to reach out to Phil Hawes, and also to, oh shoot, I just forgot his name. Trent, help me out, the engineer. Oh my gosh, I'm so sorry. Anyway, we have the original architect and the original engineers. And so when we find things that we're like, hey, why did you guys do this? Or how did you do this? They're able to answer that. But a lot of it's just hands-on experience and trial and error and practicing. At this point in time, it's pretty basic. It's proper uses of metal and silicones and seals, and understanding pressure interfaces and load-bearing systems, and understanding how to seal something in a way that's different than your household bathroom. This is a very different introduction to that, or very different application of those systems. And all of that, by the way, all of it is documented on the SAM website. If you go to samb2.space/blog, we have over 110 photo essays, 2,000 photographs. Every week I write a story about what we've done, and it tells the complete story of how we designed it, how we built it, why we did it, and what were the science objectives in choosing this material over this metal, welding over silicone, or this or this. So we're very careful and very public with everything we do, and we're really proud of what we've been able to accomplish.
Great, thank you so much. We do have.
I was going to say, we look forward to seeing you at ISDC a little over from now, and other conferences later. And Bert, over to you. Thank you so much.
I want to give, we have a couple people that raised their hands. If it's okay with you, Trent and Kai, is it okay to just answer Absolutely. 2 more questions?
Absolutely.
Yeah, sure.
Okay, I'm going to let them speak. So I've got Myrna first. So I'm going to allow you to talk, Myrna. Okay. You're all set. Just unmute. Ask your question. Myrna, are you there? You're on mute. Okay, I'm going to go to the next one while we get that taken care of. I'm going to turn it over to Al. I'm going to allow you to talk, Al. If you just unmute.
Can you hear me?
Yep, I hear you. Yep.
Okay. I just wanted to say thank you so much for your analysis of Biosphere 2. For years and years and years and years, I've been in arguments with parties that know it's a huge success. I made a couple of marketing errors, and that's about it. And it's just it's really good to hear that. It's music to my ears. And thank you very much for doing this work.
You're welcome.
Thanks, Al. Myrna, are you there? So you can unmute. Looks like you're still on mute. Okay, I'm going to allow Carl to ask a question. Carl, you just need to unmute.
How's that?
There we go. We hear you. Perfect.
Oh, yep. Okay. I was wondering if there was any consideration to introducing somehow into what is being done there at SAM to include various kinds of concepts that are being brought forth in the area of quantum biology.
I'm not an expert in quantum biology, so I cannot answer to that. Again, if that's something that a team can bring in, absolutely. If that's a portable, if quantum biology is a portable experiment and something that can be brought in as a finite experiment over a certain period of time, absolutely welcome. I love these. You guys are asking good questions and getting us to think. I'm taking notes here on the side. So
they are incredibly knowledgeable. Yes.
Thank you.
Yep. Thanks, Carl. Let's see if we can get Myrna to unmute and ask her question. Myrna, we're still going to give you a chance.
I'm unmuted.
There you go. Perfect. Go ahead and ask.
I appreciated the conversation. I'll send you the Zoom I was on earlier about meteorites from a Newark and Queens group in astronomy. It's incredible, and you'd be interested.
We'll pass that on.
Excellent.
Yep, very good. With that, everybody, I think we'll close out the night. Let me just adjust there we go. So I want to just extend our really great thank you to Kai and Trent, a really fascinating and interesting discussion. And again, it's amazing that our, Anita, you'd have to agree, our audience, our NSS members, they know so much about so many different things. It doesn't matter what topic we have for these space forums, we get such great questions. So thank you guys for answering, and we'd like to hear more about this. Hope to see you at ISDC. I want to extend my thanks to Anita Gale, our NSS CEO, for doing a great job of moderating tonight. So thank you, Anita. And as always, I'd like to extend my thanks to my colleague, Larry Ahern, Vice President of Chapters, and my colleague, Fred Becker, for as always doing a great job in monitoring and handling all the tech related here. So everybody, we thank you so much. I will share my screen one more time as we exit tonight. Let me just make sure my PowerPoint is still up there. Yes, it is. Okay, let's get share the screen. There we go. So really, it's just saying good night, thanking everybody for joining us for, again, a great space forum. We hope you will see you on June 16th. And then again on July 21st, we've got 2 great space forums coming up and 2 really fascinating books to talk about. I also hope to see some of you at ISDC next week. Wishing you a really great evening for those in our time zones. For those in tomorrow's time zone, have a great day ahead of you, and wishing you all a great weekend. And as always, stay safe. So everybody, take care. Good night. Thank you so much.
Thank you.